Really focus on virtualizing SQL. Now, if anyone came to my SharePoint session this morning, 8:30, if anyone was up and about and fresh, we're going to cover some of the initial stuff the same, so the kind of generic, how I would introduce and ensure Hyper-V is performant and effective and efficient from a platform perspective to virtualize these key workloads on. If anyone came to the Exchange session a day or so ago, I've changed the intro slides completely, so we'll be covering a lot more useful stuff, I think, than the kind of stuff we covered in that session. And then we'll go on to the SQL specifics with some benchmark testing. Oh, I'm going the wrong way. With some benchmark testing, with some reference architectures, how we can help you going forward, and how we can help you combine things like SQL with some of the stuff that's come in Server 2008 SP1 or R2 SP1 with dynamic memory. And I've got some demos and some stuff that I think will be really useful to help you if you're just starting out on this SQL journey for virtualization. So why would you want to virtualize Microsoft apps on Microsoft Virtualization? Well, in terms of what Microsoft Virtualization is all about, it's Hyper-V as this base layer, this engine, and so many people compare Hyper-V with vSphere. And VMware vSphere is a brilliant platform, it's a brilliant set of technologies, but it's just that. It's a set of technologies that is hypervisor and virtualization management. This is just our engine, our hypervisor that runs the workloads on top. So when you're making comparisons and considerations about where you go in the future for virtualization, certainly don't just think about Hyper-V. Think about the multitude of technologies that sit around it, in particular System Center, that provide that more apples for apples comparison. But these workloads that we're interested in, we've covered Exchange, we've covered SharePoint, we're going to cover SQL now. And on top of that, line of business applications, enterprise applications that are plugging into that. We've got a great white paper out talking about SAP on SQL with virtualization and some of the benchmarks we've done around that. But ultimately, the real value that helps you get the most out of these technologies is System Center. And it's something I am incredibly passionate about because if you're like me, you want to do more with less. You want to help the business strive forward, you want to blow away this whole recession, you want to drive forward into this new economy and help your business really produce exceptional results. But you've got to do it with restricted resources, with only a certain finite amount of people and time. So the System Center tools are all about enabling you, not replacing you to do that. And they provide real value add across this stack, whether it's stuff that isn't even on this slide, like hardware, storage, servers, networking, load balancers, integrating, managing, protecting, and monitoring those different workloads. Whether it's the workloads themselves running virtualized on a Windows guest, on a Windows Hyper-V platform, again, we provide value through backup, through patching, through monitoring across all different areas of that stack, right up into either regular enterprise applications or bespoke ones that you've written in-house. There's nothing stopping you writing things like management packs that allow our System Center tools to monitor your workloads that are specific to your environment only. So there's a good value add and a good ecosystem that sits around Hyper-V. But that is Microsoft Virtualization. It's Hyper-V and it's System Center. Now Hyper-V in its current release is 2008 R2 SP1, Service Pack 1, and System Center is pretty much a mixture of 2007s and 2010 releases. But they're all going to get an update towards the end of the year, and it's something we've been talking about a lot at TechEd this time round. System Center 2012, whether it's Operations Manager 2012, Virtual Machine Manager 2012, and so on. They're all getting a big, big push. But the brilliant thing for you guys is the licensing of these System Center tools is incredibly simple. If anyone understands the Windows Server licensing, where you buy per processor licensing of things like Windows Server Data Center, and you get an unlimited number of Windows servers on that particular host for your virtual machines, the same kind of thing applies with System Center. The Server Management Suite Data Center Edition, licensed per proc, gives us an unlimited number of all of the System Center tools sat on top of that particular host. So you get all of the stuff around backup and monitoring and application protection and workflow with things like a Parless now. And there's a great level of integration between all of these tools as well. But it's not over complex to purchase and it's very, very cost effective indeed. When we start to look at why you'd want to run them on Microsoft's platform, well, think about it. If you're running SQL on a Windows Guest OS, on Hyper-V, that's a single channel for support. So built-in virtualization with one-stop support. There is a partner ecosystem that's big now and really starting to grow. So partners like EMC, who I passed on the booth earlier on yesterday actually, And what they're doing around System Center Ops Manager that they haven't done before around providing that ability for us to monitor and integrate with their storage. Partners like NetApp and Dell and IBM produce excellent management packs that allow us to integrate with those tools already as well. But new partners are emerging. Partners like Veeam, who are traditionally associated with protecting and providing enhancements in the VMware environment, are coming across to Hyper-V and System Center, and they're seeing the value to plug in because they can give you more value with less tools effectively. We give you a lot of deployment options around how you deploy these applications, whether it's virtual, whether it can support you in physical world, it's up to you. But System Center with its deep application knowledge is where you get the most value. The last thing you want to be doing is trawling through event logs and SQL logs and the different types of areas you can use to analyze problems. System Center's got that built-in knowledge to enable you to obtain what's going wrong and fix it a lot more quickly and proactively in many cases. So you're seeing things that may cause bigger errors later and nipping them in the bud early on. So that's really, really important. It doesn't matter whether it's physical or virtual. So some of our competitors in the marketplace are all about virtualization. Whereas if you've got this physical database over here, no, we can't really do much with that. You'll need another management tool for that. And that's why System Center doesn't have that problem. If you want to monitor physical, you want to back up physical, you want to back up virtual, you want to patch virtual, you want to, whatever you want to do with physical or virtual, we can do both. And we're the first vendor to really push out cross-hypervisor or cross-platform support. So we're embracing Linux as a guest operating system more so now, and that's not a pioneering first. Obviously, VMware have been doing that for a while. But in terms of our management tools, managing multiple virtualization platforms, from Hyper-V, from VMware, and going forward in VMM 2012, we'll manage Xen Server from Citrix as well. You've got brilliant choice in that infrastructure. You may virtualize some stuff on Xen Server for whatever reason, some stuff on Hyper-V, and you may have an investment in ESX already. So you can embrace that single management pane across all of them. And I've talked a bit about the licensing. The way you acquire Windows servers now is vastly different from how you did it in the physical world in years gone by. You can effectively save a lot of money by being clever about licensing. And the server management suite, as part of the System Center family, really gives you that opportunity as well from a management perspective. The last thing I want to do is stand up here and talk about these brilliant management tools and how they can provide significant value, and then hit you with a huge bill at the end to say, you know what, these are unobtainable for a lot of organizations. It's not what it's about. It's very, very cost-effective licensing and great value. So what's new in 2008 R2 SP1? Well, before SP1, let's just talk a little bit about what was introduced in R2. So not everyone knows. Some people are still embracing and getting to know virtualization for their workloads, or it's, if you've come from a SQL or a SharePoint or an Exchange background, you're looking more into virtualization because you're getting pressure to consolidate, and how can we do that cost effectively? Tools that exist and features that exist within Windows Server 2008 R2 are going to make this really, really efficient for you. So straight out of the box, at no extra cost, we've got things like live migration and HA. So let's have a quick look at what that looks like. I'm going to show the live migration bit. I'm not going to show the HA bit because obviously that would require me turning off one of my hosts. And with them being in Edinburgh, that's going to make it a little bit difficult for me to switch them back on. But let's go to Failover Cluster Manager. And this is an MMC interface that ships as part of Windows Server. You can get it on Windows 7 as well. And I've pointed it at two of my nodes I've built a cluster, a 2-node cluster, of which I could have 16 nodes in this cluster in total. I've just got 2. And what I'm going to do is I'm going to open up my services and applications, and this is all my VMs that are virtualized on this cluster. And what I can do is I can pick one of these, and I can right-click, and I can live migrate this virtual machine to another node. And that's going to move it with no interruption, no downtime, from one node to another. Okay, so it's migrating across, it's using shared storage, it's using the networks in between, which we'll go through shortly, and it's moving that virtual workload across from one place to another. Flexibility. Now, I realize that's not a killer demo. It's something that a lot of us have seen before, but for some of us, that is new. And it's an example of a capability that's built into 2008 R2. But because we've got this cluster, should I lose node 1 or node 2, for whatever reason, maybe somebody unplugs it to plug the vacuum in, you know, it happens, and my server goes down, and I have a small tantrum to myself. Those VMs, those workloads are going to fail over onto another node in that cluster. Okay, that's automatic. So resiliency and flexibility to move stuff around live with no interruption. And this will become more and more useful when we start talking about SQL later on. We introduce support for a lot of the new stuff that's going on in the processors. So Intel, AMD, they're doing some cool stuff in the CPUs, and we don't want to be a blocker on that. We want to leverage it. And Hyper-V is absolutely right there, and the scalability we can achieve on newer platforms, running Intel, running AMD, is brilliant. And for SQL workloads, they take advantage of it as well. But one thing I really want to pull out on there is has anybody deployed Windows Server 2008 or R2 in server core mode? Okay, a few brave people. Brilliant, excellent. So the reason you do that is a lower footprint, less patching, reduced attack surface, a number of other different benefits. But it's a little bit trickier to manage in terms of locally, because you need to be on board with the command line commands, netsh and a number of others, which is tricky for some people who've come from a pure GUI background. But if you want to embrace server core, that's fine, but workloads like SQL, you can't put those in core. It doesn't do everything that full GUI installs do. However, you can enable Hyper-V in there. You can enable Hyper-V in the core mode. And the benefit there is, again, this reduced attack surface, this fewer running services, reduced patching, but also the efficiency of Hyper-V combined with that. But that's up to you. It's a deployment decision you make at deployment time. But two of the new things that were introduced in Service Pack 1, number one is Remote FX, and that's really around virtual desktops. And there's some brilliant demos down on the show floor if you want to check those out, of some of the partners like HP, Quest, Citrix, and so on, showing some really cool integration with Remote FX. But the one where we're concerned today, because it's going to have a direct implication with SQL Server, is dynamic memory. And dynamic memory is let me flick over to my demo box, and let me go to Hyper-V Manager. Dun, dun, dun. Here we go. There we go. So this is Hyper-V Manager, another MMC interface, and dynamic memory is a solution that exists as part of Service Pack 1 that allows us to optimize the use of physical memory from virtual machines. Okay? And you'll see, hopefully, what you'll see on here, there's three columns: assigned, memory demand, and memory status. If we look at the memory demand to begin with, you'll see that some of my VMs have got differing, quite random figures for memory. 931 megabytes of RAM, not something you typically assign to a virtual machine if you were doing it statically. But what this is the actual demand that guest operating system is exhibiting through to Hyper-V. It's saying, hello, I'd like 931 meg to do my job at this point in time. Can you give me that, please? And Hyper-V is saying, you know what? There's no contention on the system at the moment. Here's 931, and here's a little bit extra as well to tide you over. That's something called the buffer. And if I bring up the settings of this particular VM and drag this over here so you can see, the settings, I go to memory actually, just so we can see, you'll see the buffer by default is set at 20%. Now you can drop it down to a minimum of 5 or up it to, I guess, 100. But what the buffer is doing is just giving you that extra bit of headroom just in case things fluctuate slightly. And this weighting here, whether it's high or whether it's low, think of this as a priority. So if the host starts to get contention exhibited on it, for an example where you've got a lot of virtual machines all needing their RAM at the same time, in that scenario, some of your VMs that are high in terms of weighting are going to have RAM taken away from them last. Okay, so these are your higher priority virtual machines. You might want to put SQL in that kind of bracket. Okay, and we'll touch on that a bit later on. But that's a bit about dynamic memory, and it's giving us that flexibility to, instead of saying, you know what, I'm going to give this file server 8 gig, and whether it's using it or not, I'd lose 8 gig from the host. Instead, we can say, well, I'll give it a maximum of 8, and I'll reduce the minimum, the startup memory, to say 2 or 3. And Hyper-V will manage the memory in between and allow us to reclaim it if it's not being used and give it if it's required. And you can see that if you do inaccurately capacity plan some of your workloads, like I have, and this isn't a reflection on what we're going to talk about later on, but it's a good example of where I haven't followed best practice, and I've only specified a maximum amount of RAM to this SQL VM of 3 gig, and yet it's requiring as a workload, because it's quite busy, just over 4. So it's saying, you know what, I'm going to give him a warning, and I think you should more accurately right-size this virtual workload, something to bear in mind. But ultimately, dynamic memory is allowing us to achieve better levels of scalability, greater levels of density, without sacrificing the performance, because it's a guest-aware capability. And what I mean by that is we can't achieve dynamic memory benefits through older operating systems like, for example, Windows XP, because they don't understand how to interact with the system. Newer operating systems like Windows Vista, Windows 7, Enterprise, and Ultimate, and the server operating systems, 2003, 2008, and 2008 R2, can all take advantage of it. Okay? But what I'm going to go through now is some guidelines to help you size your hosts, help you plan for capacity, plan for resiliency. So no matter what the workload is, whether it's Exchange, SQL, SharePoint, custom stuff, file servers, no matter what, if you follow these kind of guidelines for a solid foundation for Hyper-V, you'll be in a good place. So first up, memory. A lot of people overlook the fact that the host that's running on the physical hardware does need a bit of RAM itself. It's not just the virtual machines. Everyone thinks, well, I've got 10 VMs on there, they're all 4 gig each, that's 40 gig total, I'll get a server with 41 gig of RAM. Just give it a minimum amount. That's not the case. You need to think at a little bit more granular level. And the way you do that is think as a minimum, half a gig for the parent OS, so half a gig for the host, allocate that to one side. And then for each VM, and this is when you're capacity planning, you realize that these figures will fluctuate as you move workloads around. But for each VM that you're going to run on that particular host, you allocate 32 meg for the first gig of RAM and 8 meg for the subsequent 1 gig of RAM. So for a 16 gigabyte virtual machine, an individual 1 VM, you've got 32 meg for the first gig, and then 15 times 8 meg for the subsequent 15 gigabytes. And that gives us a total of 152 meg. So the overhead of running that particular VM on Hyper-V, in terms of the parent partition, the parent host, would be an extra 152. So we'd be looking at 512 plus 152. That's how you work it out. Now if we had 8 of those virtual machines, that would be 152 meg times 8, which is just over a gigabyte extra. Okay? These figures are not specific to Hyper-V. Okay? VMware have exactly the same kind of things that they have to adhere to, but you'll struggle to find it on the web, even if you're using your favorite search engine, which I know is Bing. When it comes to networking, this diagram view here, it's just relating to networking in a second. It's probably the biggest question I get. How is it best to configure networking from a VM perspective, from a host perspective? There's a little bit of head scratching goes on. Do I need this many NICs? What is the best practice? I've got this from there's a brilliant NetApp guide. If you do a search, again, using your favorite search engine, you do a search for TR-3702, and you'll find a great article written by the Microsoft Business Unit within NetApp. Irrespective of the storage, the networking guidance is brilliant. It's easy to understand, it's easy to follow, but at the same time, it's clear, concise, and it reflects what you may be doing in your environment. And this is a common scenario here for a single host that's in a production environment. You'll see we've got a NIC dedicated for management, okay, 1 NIC in this case. We've got 1 or 2 for virtual machines, for the traffic that's going to come in and out of those virtual workloads. In the iSCSI example, we've dedicated 2 for that. Okay, that's important because you want resiliency to your storage, multiple paths. And we'll touch on MPIO in a minute. If you're using fiber, don't worry. And then the final 3, 1 network for cluster. That's also known as heartbeat in some cases. So some people refer to that as a cluster heartbeat. Now, depending on who you speak to, you may find that they say, well, you know what? You don't really need a dedicated heartbeat network anymore because there are common networks between the nodes. The heartbeat will just hop on the back of those. Okay, so you don't necessarily have to give a dedicated network to Heartbeat, but I would still recommend it, okay, in a production environment. And then you look at migration and CSV. And migration is the network that I just used to live migrate that virtual machine across. So a dedicated live migration network that can get saturated with traffic as we move a VM from A to B. And then finally a cluster shared volume network for extra levels of resiliency and integration with the storage. And some backup tools utilize that as well. Now, one thing that often catches people out, and it's a little tip of the day when it comes to the live migration network, is people build clusters, but then they forget, they don't necessarily know, oh, where do I set this live migration network? There's no obvious tick box anywhere for me to say, that's the network that I want to use for live migration. Now, it's hidden away. All you need to do is create a random virtual machine. Any virtual machine doesn't have to have an operating system in it at all. Click on it. Click on the middle bit here, Properties, and you only have to do this once, and there'll be a little tab saying Network for Live Migration. There it is. And you just choose the one that you've dedicated. And that NetApp guide, that TR3702, will walk you through the different selections and where you'll turn things off and turn things on. Very, very useful indeed to scope out your networking on Hyper-V clustering. So I'm going to cancel out of there. That's a little tip, because not everyone knows where that is, and they'll just assume it's choosing the network they want to choose, but that's not always the case. Go back. So 7 or 8 NICs for iSCSI-based solution in production. 5 or 6 if you're using fiber. And you're going to say, well, that's not too bad. That's 2 quad port cards, or it's 4 dual port cards. But I haven't really touched on teaming there, because they're individual NICs. There's no resiliency in those. So you may want to think, well, I might actually need more NICs than that for resiliency purposes. And when it comes to networking and optimization and teaming, we still, as of today, still partner with the NIC vendor, whether it's HP on HP servers, Broadcom, or whether it's Intel. So you'll get the drivers from the OEM. That's my biggest recommendation. If you're using Dell hardware, go to Dell's website. If you're using HP and Intel, go to HP's website, grab them from there. If you're using Intel, they'll typically come from the server vendor's website anyway. You could go off to the NIC vendor's website directly, like Broadcom's or Intel's, but I would make sure you stay with the OEM, because those are the ones they've validated and tested and done that extra quality control. Okay, you don't want to be caught out, not when it's something as fundamental as the NIC. Now, when it comes to storage for the host, if you want to do clustering, like I just showed a minute ago, you're going to need some shared storage, whether it's iSCSI-based fiber or FCOE. We do recommend a minimum of a gigabit. More and more people are thinking about 10 gig. Is anybody running iSCSI storage today? Yeah? And everyone else fiber? Yeah, okay, cool. Anybody running 10 gig iSCSI? Okay, 1, okay, oh 2, sorry. I think if I ask that question next year, I think it will be that bit more, and I think going forward it's going to become a default as more and more people looking to send more stuff over the wire and do more with virtual machines and consolidate more aggressively. But I certainly think today gigabit is a great platform. 10 gig's obviously advantageous. If you're enabling jumbo frames, make sure you're enabling it on all the components that make up your network infrastructure that are going to connect all of these things together. Don't, like I did, enable it on the hosts, but not on the switch, assuming it was enabled by default on the switch, and when you can't ping with these bigger packets and your storage is getting disconnected, then you realize what you've done and you go and cry in a corner for a short amount of time, an embarrassment. If you're not using shared storage, if you just want to do this on local storage, that's fine. That's fine. You can use normal disks that exist within servers, SSDs, or whatever. It's entirely up to you. But certainly utilize, and don't be afraid of utilizing, the built-in iSCSI initiator and MPIO capabilities built into Windows Server. So if we look at one of my hosts, in fact, let me just spin up a connection to it. Just while I'm doing that. Hypernode 1. Just connect in my credentials, because what I want to make sure you understand is that you don't have to implement necessarily dedicated iSCSI HBAs. You can use normal network cards as well if you want. The performance of those is typically pretty high today. If I move this across, we'll have a look. Hopefully you can see that okay. If I go into iSCSI, now the search is always dependent on spelling. And again, I can't spell there. ISS. Right, let's just go IS. There we go, top of the list. Now you'll see here, if I make this a little bit bigger actually, there we go, that's better. The iSCSI initiator, all you literally do, if you've not used the iSCSI initiator before, you bang in the IP address or the DNS name of the target you're looking for and click Quick Connect, and it's going to pretty much set everything else up for you. And you'll see I've got 4 LUNs, four logical units of storage that are presented to my hosts in my cluster. But you'll notice they're MPIO disks, okay, in multipathing. Now my big recommendation for MPIO, which I can spell, there we go. And let's bring that up. MPIO and iSCSI just server features, server capabilities you can enable. When it comes to MPIO, Microsoft has a framework built into Windows Server 2008 R2. So by default, you can get going with MPIO, multipathing, and use different types of load balancing and resilience. However, if you're putting this in production, I recommend getting hold of the storage vendor's device-specific module, DSM. And what the DSM will do is optimize the load balancing and resilience configuration of your multipaths based on what they believe is optimal for their storage. Okay? Ours will work fine, but I would recommend using the storage vendor's DSM. Okay? Something to be aware of. And you can usually download those from their website, or they'll come with their usual storage utilities. Just pop it on the relevant nodes that are going to be connecting to the storage. Now, we don't penalize you for utilizing a third-party DSM for enhanced load balancing or storage optimization. You know, there are vendors in the market that you need to buy the high-end SKU to be able to do that. You know, you can have the free Hyper-V server that you can download off the web and still use those load balancing capabilities. So when it comes to the guest OS, and now we're starting to get a bit more specific about how we tune operating systems for our key workloads. Firstly, ensure the integration components are present. These ensure that the guest OS performance is optimal. And it's a simple tool, it's simple to implement. All you need to do is, if it's an older operating system like 2003 or 2008, doesn't really sound that old, but yeah, if it's an older OS, not the most recent release, you would go in the Hyper-V manager, click on the VM, click Insert Integration Components, and it's like inserting a mini DVD into the VM that installs some drivers and optimizes. The first time you do it, it will require a reboot. However, if you're running new operating systems on Hyper-V R2, like Windows 7 and Windows Server 2008 R2, they're bedded in by default, so you don't need to install them manually. They're there to begin with. Okay? And they will ensure optimal performance of both storage, networking, the driver stack. You'll have a better experience with keyboard and mouse as well. Now, when it comes to networking, let me just bring up very quickly let me minimize that out of the way and minimize that one and go back to Hyper-V Manager. Now, if I look at one of my virtual machines here and go to Settings and bring this across here, you'll notice I can add two types of network adapter, synthetic and legacy. Synthetic is high performance, legacy is not. Legacy is used, I would say, solely for PXE booting because it's got a driver that exists pre-Windows, i.e. pre-boot. The synthetic NIC doesn't. Okay, that will only have its driver once it gets into Windows. Okay, so if you want to PXE boot an OS that's virtualized, you need to use the legacy NIC. But you can add up to 4 legacies and up to 8 synthetics, so a total of 12. Okay, so you've got that scope there too. You shouldn't necessarily need, too frequently anyway, a legacy NIC, but the performance is less. Okay, so where you can, definitely make sure you utilize the synthetic NIC. And take advantage of the in-guest performance options. So just like in the physical world, you can turn on jumbo frames for enhanced performance through to the SAN. You can turn on TCP offload, large send offload, those different NIC capabilities. You can do that in virtual machines as well. And there's going to be certain workloads that will like that and will take advantage of that as the higher throughput is achieved. So certainly think about, they'll be on by default, and you shouldn't really need any reason to turn them off. Now when it comes to storage, if we go back briefly to my XP machine that I had here, you'll notice that this VM has got an IDE controller. In fact, it's got 2 virtual IDE controllers, and I can add SCSI controllers as well. Now, similar to what I said before about the legacy network adapter, when it comes to IDE controllers, these are the only ones you can boot off. So if you're creating a VHD that's going to be a bootable VHD, i.e. containing the operating system, you're going to want to attach that to an IDE controller. Secondary drives that are holding data and logs and that kind of stuff, attach them to the SCSI controller. That's fine. And it supports hot add. So while the VM is running, you can hot add disks and remove disks from that VM. But one thing that catches a lot of people out is they think, okay, I'll add a secondary disk to a SCSI controller, and then I'll put the page file on it. But the SCSI controller, just like the synthetic NIC, the driver is only loaded once it gets into Windows. The page file is created before that. So if you want to put a separate drive, a separate VHD, a virtual hard disk, for the page file, attach it to the other IDE controller, okay? And that will work fine. So just something to be aware of. Obviously, you're going to size VHDs appropriately for the contents. That would be a little bit silly, but you can extend them, don't worry. But when it comes to choosing VHDs, when we talk about SQL in a short while, what you'll find is that SQL, Exchange, SharePoint, they all benefit from fixed size virtual disks. Okay? And a fixed size virtual disk is a buy now, pay now approach in terms of I want a 40 gig VHD for my SQL VM, I lose 40 gig on the SAN. Dynamic disks, on the other hand, which are buy now, pay later, in the sense that I want a 40 gig VHD for my SQL VM, okay, you can have it, but it starts at 0 megabytes. I install an OS, it grows to 10 gig. I add SQL, it grows to 12 or 13 gig, etc. And it continues on as you add more stuff to the contents. So the contents of that VHD typically reflect the size and the stuff that's inside the OS. Fixed, however, if you said you want a 40 gig VHD, it'll be a 40 gig VHD and you'll lose 40 gig on your SAN. But it does offer the highest performance, okay? More so than dynamic. And for SQL, as a workload, it's very, very important. When it comes to utilizing ingest, don't be afraid as well, if you've got virtual machines running on your platform, to utilize the same capabilities. Let me just bring it across here. Imagine this was a virtual machine we've just logged into. There's nothing stopping us hooking our virtual machine with the ingest iSCSI initiator straight into our iSCSI SAN. Nothing's stopping you doing that, and many, many organizations do that today. So they hook their VMs as secondary drives directly onto the SAN. Irrespective, so they're not using VHDs for those secondary disks, they're going straight there. And that's a great level of performance for that as well. Okay? But you can only do that with iSCSI because of the guest initiator, the iSCSI initiator. There isn't a virtual HBA to hook onto a fiber SAN. You would have to use VHDs if you're using fiber. Okay? So let me bob back. Now, I've touched on dynamic memory already, so I'm not going to go through it again, but it's certainly important when we start to think about SQL as a workload. But important to know, as I said before, not every guest OS will work with dynamic memory. They do work together, so Hyper-V is accurately listening to what the guest OS needs and saying, yeah, okay, I'll give you that RAM, I'll take it back, I'll give it you again, I'll take it back, I'll give it to him, I'll take it back. It's being efficient around that addition and removal. But let's look at some of the performance stats around Hyper-V very briefly. SQL is a workload that likes things like memory. It's an intensive workload. It likes CPU as well. Let's be clear with that. But in terms of some of the stuff that proves Hyper-V as an enterprise class hypervisor, when virtualizing workloads like terminal server, which is typically quite a memory intensive workload, we saw that on newer hardware, i.e. within the last 2 or 3 years, that's got things like hyper-threading, which is making a bit of a comeback. Virtual machines running terminal server 32-bit on Hyper-V and Zen server were 15% better than vSphere. And that's not to say, oh, vSphere, that's really bad. No, not at all. What it's trying to say is, you know what? You could virtualize with confidence on any of these 3 platforms for a workload like terminal server. It's going to be that little bit better on Hyper-V, obviously. I'm only joking. But when it comes to scaling it up with 64-bit terminal servers, Hyper-V and Zen server very, very close to bare metal performance. vSphere a little bit further behind, but again, within acceptable limits. We've seen, and anybody who's deployed Hyper-V will know it's pretty straightforward. Deploy Windows Server, tick the Hyper-V box, reboot, and we're good to go. Okay, we've got the ability to virtualize. So it's easy to get up and running, and that's in 2010 what ESG, Enterprise Strategy Group, proved as part of a white paper. Easy to get going, very quick, provides HA and live migration that we saw before out of the box, and it's very close to physical performance. Okay, and this white paper that also goes on to talk about the scalability. So across 16 nodes in a cluster, again, I don't know why I'm doing this to represent 16 nodes, a big cluster I can hold in my hands. We scale to 1,000 virtual machines, but you don't need to use 16 nodes to hit the 1,000. We support 384 VMs per node. Now, just because you can, doesn't mean you should. You know, it doesn't get away from accurate capacity planning and sizing. I'm yet to meet anyone who's running over 300 virtual machines on a single host. Fair play if you are, but still, you can scale. But you'd spread out your workloads more than that. But it could be done if you wanted to do, and you would be supported. Now, in terms of disk performance for SQL, we'll look at this in more detail later on anyway, but SQL databases, for file servers, for Exchange databases, the performance of disk I/O is very, very close. So again, you're not sacrificing much to actually go into this virtual world. And the final test for Hyper-V specifically before we move into SQL. When it comes to iSCSI, we've shown already one of my hosts was hooked directly via an iSCSI initiator onto some shared storage, a SAN, an iSCSI-based SAN. But when Intel launched the new at the time 5500 processors, the Nehalem, and combined that with their new Intel 10 gig Ethernet adapters, what they found is they could push in hardware 1 million IOPS across that link. It's a huge amount of scalability. And right through to a virtual machine, it was well over 700,000. So again, great scalability, more than most organizations will ever need in terms of throughput. Okay, but it's there for you if you need it. And you can see, particularly on the graph on the right, as you move towards the higher block sizes on the bottom of the graph, you'll see that the lines at the top converge. And that's indicating that Hyper-V and native are as one. Okay, so the performance is very, very strong there. So anyway, getting on to SQL specifically. ESG ran some tests to build on what they'd done in 2010, but these were specific to workloads, because what we want to ensure is that organizations that are evaluating virtualizing their key Tier 1 and Tier 2 applications and workloads can do it with confidence on our platform. Okay, and this is what the ESG tests were all about, and you can download each individual test for SharePoint, SQL, Exchange, and there's also one for SAP, and a generic document that talks more about the processes they went through. But what they ran it on was pretty impressive. Okay, so the back end was EMC storage, fiber channel disks, 155 of them, 15K, so not SSD, but pretty quick SAS disks. And they split the disks in such a way that allowed them to optimize where they placed the virtual disks from the virtual machines. So they separated disk pools for data, for logs, for operating systems, i.e. VHDs that contain the guest OSs themselves, and the application servers as well, particularly in the instance of SharePoint. And they had a number of blades, each dedicated to running these workloads. So SQL, SharePoint, Exchange, and so on. Now, I've done a test in the last few, in the few sessions I've done around server envy. My servers are 24 gig of RAM, not particularly high end. So can anyone beat 128 gig for a single server? 256? 384? Go on. 512. You're the third person I've met with 512. Again, I'm crying a bit inside. It's not fair. If you can spare any RAM, that would be great, to up my capacity. But yeah, that's an indication of, and how many processors? 4? Yeah, that's amazing, you know. 4 processors, how many cores? 8 cores in each. Okay, so 4 processors, 8 cores, so what's that? 32 cores total, 32 logical processors, and 512 gigabytes of RAM. That is immense. You can consolidate a huge amount of infrastructure down on that, okay? And that's just an indication of where we're going today. These servers are more and more affordable, and as the DIMM size or DIMM prices for the larger DIMM sizes start to drop, so 8 gig DIMMs and 16 gig DIMMs, easy for me to say, become more affordable, what you'll find is that these larger server sizes and these more aggressive consolidation opportunities exist. But yeah, that's impressive. But then what did they do in the virtual world? So in the virtual world, specific to the SQL testing, they had one physical server, okay, running 2008 R2 SP1 with Hyper-V enabled. They weren't using dynamic memory. Okay, they weren't testing the new features. They were just a base install. They separated their virtual machine OS images on VHDs from their SQL data and log VHDs. So that's similar to what we were talking about before, about using fixed VHDs but separating them out and attaching them via that SCSI controller. Okay? And as guest OSs, they only ran 4. They had 16 gig of RAM each in the VMs. And remember, a Hyper-V VM can scale up to 64 gig of RAM per VM. So still a bit of headway there. But they'd hit the 4 vCPU max of Hyper-V. So each Hyper-V VM can support up to 4 virtual processors, okay, today. I don't know how that will change in the future. I wish I did. But no, at this time, it's 4. And that was pretty effective for the test, as we'll see. So they scaled out 4 SQL VMs across this single physical server. And how they tested, they used a simulation to simulate, as you would, an OLTP application, an online brokerage application, across the 1 through to 4 databases. And they managed 20,000 customer databases per virtual machine. Okay, so they scaled it up 20K, 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 20K. But they didn't do anything special to SQL. And this is what I find is quite interesting. There'll be people in the room who have SQL skills that will be immense. And they'll be able to tune and tweak SQL just off the top of their head. But in this case, they just use the out-of-box settings. You know, install, next, 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 finish. Let's get the databases in, and off we go. So these are their out-of-box settings. And what they found is these customers scaled linearly across the 4 workloads. So 20,000 customers on one VM, up to 40, up to 60, up to 80. Remember, this is on a single server across these 4 VMs. We're not separating it out across multiple hosts. But look at the response time. The response time only increases that very slight amount to between 100 and 200 milliseconds across those 4 workloads, handling those 80,000 customers. Now, that's an indication of the performance is very, very high in that environment. But we look at the transactions per second. Inevitably, that's going to increase as we add more capacity and resource. And you'll see as we went from 1, 2, to 3, to 4, the transactions per second is increasing and increasing. Not linearly. It's not going up as a direct straight line. It's starting to tail off a little bit at 1,800 transactions per second. But it's still a high level of performance for these workloads. Remember, this is on just one host. And remember, this is also just utilizing 4 virtual processors in the guest operating system. Okay? So if you're hitting those limits with vCPUs, that's where you're going to have to make the decision to scale out onto more VMs. But with SQL licensing, as I'm sure you're aware, with enterprise and data center licensing, if you choose to cover the procs in the hosts, you can run as many instances and as many procs in virtual machines as you like for SQL, particularly with SQL Data Center Edition. And when you get from the batch requests, again, the VMs are up the side this time, just to confuse you. You know, we're pushing real scalability metrics here as you go. One VM just under 1,500, up to over 2,000, up to nearly 3,000, and over 3,500. So the transactional workloads and the requests coming in are being handled efficiently by the VMs, even though this is a virtual workload. But everyone's going to think, well, what would a physical server do? Because it's physical would blow it away. You know, I assume that's the perception in the infrastructures out there. SQL, you know what? I'll keep that on physical. Very, very close. You know, the physical workloads running the same tests, it's within 10%, if that. Okay, between 700 and 800, the gap. Okay, so very, very close to physical. So don't be put off and don't be scared about virtualizing SQL on Hyper-V. So across those VMs, we saw low response time. It was nearly linear in terms of scalability for both transactions and batch requests, although transactions did tail off a little bit as we were getting towards the 4 VMs. But that overhead was very, very small. Now that 12% will reflect not just what we saw in the batch requests, but also the transactions and so on. But either way, it's an acceptable level of performance hit compared to the benefits we're going to get looking at virtualization very shortly. So what they found in summary, low response times, okay, low performance impact of Hyper-V. For the vast majority of end users and applications won't detect that performance difference. So be confident. And the performance, scalability, and low overhead of Hyper-V can give you benefits. You know, it can give you benefits versus scaling out lots of physical SQL workloads and licensing them accordingly, okay, with physical infrastructures. But inevitably, there's the old caveat, mileage does vary. You know, you'd need to test with your workloads and your specific data. But certainly Hyper-V is there. It's free within Windows Server 2008 R2. It's a free download off the web as part of Hyper-V Server 2008 R2. And if you're going to start this off, don't get your biggest, baddest, meanest database initially and go, right, you're the one. Here we go. Start with the smaller ones. You know, get used to it. Test the performance, benchmark against what you've expected in the physical world, then move, as you grow in confidence, move with those larger databases that are perhaps more mission critical. But more and more people are starting to adopt. Okay, more and more enterprise workloads are starting to go on virtualization. But just out of interest, who has any SQL databases that are more than 32 gig of RAM? Thought you might. And there was quite a few actually, more than 64. Yep, I'm guessing why now. Now I realize why you've got that massive server. More than 128 gig? Wow, okay, so just you. So you wouldn't be able to virtualize that particular database in Hyper-V because of the 64 gig. But this is a good thing because if you've got a really high-end database that's getting really hammered in the physical world, you're not going to gain a huge amount by virtualizing. So having that hat on in the real world and thinking, you know what, I can consolidate a lot of my stuff, but that one's going to stay physical, fair enough. You know, that's the decision you make. But in terms of a lot of virtual work, a lot of SQL Server instances have 32 gig or less, 65% have 8 gig or less, and 20% have 2 gig or less. That could be SQL Express, it could be SQL Standard Edition, just powering small applications. But either way, there's opportunities to consolidate. So let's have a look at some best practices. And what I want to show you is I want to try and help you overcome a common problem that exists in a lot of infrastructures. Physical server sprawl affected a lot of us before virtualization came along. Now virtual machine sprawl affects a lot of us because it's so easy to create virtual machines. But SQL sprawl is something that a lot of organizations suffer from, or database sprawl in general, because not everyone can put their finger exactly on and say, you know what, I know where all of my databases are. Because different people within the organization are installing apps that install database backends, or they're random people are creating databases all over the place, and you can't keep a track on them. It's very difficult unless you're a very controlled organization. But what if you're running non-Microsoft platforms? What if you're running Sybase or Oracle and you're thinking, you know what, I'd like to go to SQL with some of the new stuff they've put in the, for example, 2008 R2. How can I get there? How can I consolidate? So what I want to talk about is, very briefly, is before virtualizing, how we can help you consolidate, how we can help you assess and inventory what you've got before you virtualize. There's no point virtualizing all of these tiny instances of SQL if you can consolidate them down more effectively at the SQL layer first and then virtualize them, because you'll see dual benefit from that perspective. So you'll see we can reduce down the schemas, the databases, down to the instances, then start consolidating at the virtual machine level. And the more we group these resources together and increase the density, the lower the costs are to run these typical workloads. So how can we start you getting started? The sentence didn't really make sense. Let's have a look at the Microsoft Assessment and Planning Toolkit. Now, has anybody utilized or seen or used maps before? Okay, just 3 or 4, 5, 6, more hands going up. So let me give you a quick heads up for those of you who haven't seen it. Here we go. And there we go. So, the Microsoft Assessment and Planning Toolkit, if you've not seen it before, it's a free download. Version 5.5 is the latest version. And if I open it up here, it does 1,000,001 different things. Well, not technically 1,000,001, but it does a fair few. It needs its own little database at the back end, another database to manage. Only a small one, though, this time. But what it can do for the organization is it can inventory client-related stuff like Windows 7 readiness. I want to see if all my laptops will support Windows 7, yes or no. And it will go out and scan in an agentless fashion whether that is applicable or not. Same for Office 2010, Internet Explorer-related things as well. It'll do virtual machine capacity planning, but it'll also do a lot of stuff around databases, as you can see on the right-hand side. So I'm going to start the inventory and assessment wizard, and I'm not going to check for Windows-based computers. I'm going to be checking for SQL and MySQL and Oracle and Sybase. And it's not just on Windows platforms either. Okay, it's on non-Microsoft platforms as well. Now, what you'll notice here is it can do all of these other things. And to install maps, you can put it on a laptop or a server and just leave it running for a period of time. So we'll go next on this. How are we going to discover? There are multiple different ways. We can put an IP range in, we can bring in a file of computer names, or we can just use, in this case, AD. We'll put in some credentials, .msft, and we'll put in a backslash, there we go, and an extremely secure password, I'm sure none of you could guess. It's definitely not a password, honestly. And it's going to go across and find all of those virtual machines in that domain. We need to give it an account that's going to be able to query that. So ours is just going to be the same. Boom, and then the password. Boom, and password. Boom. And we'll save. We'll go next. That's fine, ports are fine, great. And remember, this is agentless discovery, so it's going to go out and it's querying. And I would leave this going for, it may take a few minutes, it may take a few hours, you'd leave it going. And it would go away and it's going to query different elements of your infrastructure and find out just what's out there from a Windows, from an Oracle perspective, from a Sybase, from a MySQL. So we'll close that down. We'll go to the discovery and readiness And we'll look at Microsoft SQL Server, not called Michael, and you'll see that it's discovered a number of different versions of SQL, so 2008, 2005, a couple of counts and a few more instances. And it's presenting that in a graphical format that's easy for us to understand. And if we scroll down a little bit, you can see the versions of SQL we've discovered are Enterprise, Express, and 2005 Express. Okay, so we found some different versions, different instances. What this is arming us with the knowledge to do is understand where these exist, where they're located from a computer perspective, then we can start to perhaps consolidate them down to virtual infrastructures. We can discover things like Oracle as well, so we just found one sneaky deployment of Oracle 10.2 in there. It's crept into our infrastructure, but we found it, don't worry, and we'll be able to utilize the useful information at the bottom here for the SQL Server Migration Assistant for Oracle to move it over to SQL Server with a minimal amount of effort. So again, we're providing links and useful information if that's what you want to do. If not, that's absolutely fine. You're finding out where these things are located, which is more to the point. Let's just have a look at those machines in particular. Let's expand this out. And you'll see that the particular computer names we found, so there are two, there's one there and one here, and you can see the different things we found and located on there. So it's useful as quite a bit of a software inventory as well. Now, let me show you some of the reports that get produced, because this is pretty raw data in its current form, and I'll show you a bit more as well. But once we've gleaned all the information from our infrastructure, we can use maps to produce some reports. And these reports will contain all the relevant stuff we want to provide to the business to say, here's the advantages of SQL, here's the advantages of consolidation and virtualization, and so on. I'm not going to run all of those, but those are the ones you can run from here, using the data you've gathered. So we'll cancel out of those. There's lots of different reports. But let's close that down, because I've got the reports already built with some sample reports. And if you download the map tool, you can view some sample reports and the kind of stuff that they give you. But if you look, these reports don't match what we've just scanned for, but they're just giving you an idea of what you can find. So we get information about the different components that make up SQL that we found in our infrastructure, how many of the databases, integration, analysis services, the instances we found out there and the servers that they're sitting on, and also the product type that are running. So in this case, a lot of them are SQL 2008 R2, 2008. There's some 2000s in there as well, SP3, and we can get all that information from here. And finally, the component versions as well, relating to analysis services, reporting, and so on. Let me show you some more. Database details here as well. So for every version of 2000, we've got 9 instances there. We've inventoried 6. We couldn't get to 3, and we found a total of 42 databases as part of that. And we can click through each of these tabs, provide us information. But as you can imagine, there's a lot of stuff in here. You need to digest this slowly. Okay, there's a lot of things that we can find about the instances, the users who are accessing, and so on. If I look at some of our more interesting reports, you'll see the SQL Discovery Report. This is more of a report that we can present back to the business with lots of nice pie charts, lots of nice graphs to say, this is our split in terms of our different versions of SQL we've got out there. This is how we can consolidate. Why would we want to migrate? Different editions, different components, and different operating systems they're running on. It's just arming you with lots of useful information. So final couple, migration discovery. So it's found stuff that isn't on Windows platform. It's found a MySQL instance running on Fedora. It's found a MySQL running on Red Hat. It's found MySQL running on Windows Server. It's found Sybase running on Red Hat as well. Okay, so it's found all of those different platforms or database platforms running on different operating systems. And finally, a migration proposal. So if you were thinking about migrating off either MySQL, Oracle, or Sybase, the documentation can really help you with that. And you can see there's lots of useful information in there, what we found, how we can move you across, guides to migrating from different platforms over to SQL, if that's what you want to do. You close some of these down, close some of these down. But consolidation is only really half of the story in terms of consolidation your SQL. What about the virtualization? How can we help you now that you've consolidated your SQL instances and your databases down? How can we help you go from that physical to virtual? And that's where System Center comes in. So System Center Virtual Machine Manager can allow us to convert physical servers. If I look at the properties of this particular host, it's got a bit of resource left over, it's got a bit of capacity, so it could take another VM. And if I click Convert Physical Server, it would bring up a wizard that allows us to walk through conversion of a physical machine into a virtual. You may choose not to do that. You may choose to migrate the database separately and create a fresh SQL virtual machine. That's up to you. We give you the choice. And as I said, we could click Convert Physical Server, and it would start off that process. We'd point it at one of the physical servers we'd found, with SQL running on it, and convert it. Okay, if you want to do it that way. So cancel out of there. Yes. And jobs are good in. So let me bob back to the slides. So that's how we can utilize the map tool to help us consolidate, because the last thing we want to do is overcomplicate our consolidation by consolidating stuff that isn't necessary from a VM perspective. And we've discovered, and then we've introduced Virtual Machine Manager, which can help us P2V those workloads onto Hyper-V. So a lot quicker adoption. But what about performance? How can we ensure that? From a Hyper-V perspective, as we've said, the VMs are limited to 4 virtual procs. And it is a recommended ratio, and this is important, of physical cores to virtual CPUs being 1:1. We'll support 2:1, but it's recommended 1:1. So for every physical core you've got in the host parent, one virtual processor will map to that. Okay, that's the recommendation from the SQL team. Other workloads, you're fine. We support for most workloads 1 physical core to 8 virtual processors. But for the SQL guys, 1:1. Okay? But we'll look at some performance testing in a few minutes that actually shows when you go past 1:1, the performance is actually still really, really good. But from this perspective, so if you had a 16 processor or a 32 in the example of the gentleman at the front here, 32 logical procs in his box, irrespective of hyper-threading, don't count them as 2. Okay, it's still full cores. That would be 16 virtual CPUs in the guests. So that could be 16 VMs with 1 virtual processor, 8 with 2 virtual processors, or 4 with 4 virtual processors. We do not support snapshots on the SQL workloads. Okay, Hyper-V snapshots. If you're not sure what I'm talking about there, very briefly, let me go to Hyper-V Manager. You'll see one of my VMs, I think it's here. This one here. This one's got a snapshot on it. So it's a point-in-time snap where I say, I'm happy with that up to this point in time. I'm going to snapshot the VM, and then I'm going to continue using it from that point forward. And if I need to roll back to that point in time, I can just restore the snapshot. Now for test and dev and workloads like that, that's fine. But for production workloads of SQL, the SQL team do not support that. And it's the same for Exchange, and it's the same for SharePoint. And when it comes to networking, utilize those synthetic NICs and enable the VNIC optimizations. And what that means is enable jumbo frames in there if it's going to benefit the workload. If you're connecting directly to the storage, make sure you've got things like TCP offload and large send offload enabled to enhance performance. Use the fixed size VHDs and use the map tool like I just did if you need to start on that process. If you're already virtualized or if you already have a good understanding of what SQL you've got, in fact it's on that server and it's right in front of you and you can touch it, fine. But the map tool might actually result in some unknown databases creeping up. But planning for HA. Now this is important from a how do I architecturally lay out SQL. Okay? The SQL guys who've come from a SQL background, they'll be like, our HA is the best. It provides mirroring or clustering at the SQL level, the utmost performance and resiliency. Absolutely, that's right. But the Hyper-V guys on the other side, they'll be like, nah, just run it in a single virtual machine, a single database server, single SQL server in a VM, but run it on a cluster of Hyper-V hosts. That's resiliency, and we can live migrate your VM around. You can't do that with your SQL clustering, can you, Mr. SQL? But actually, we support the best of both worlds. We support officially guest clustering on hypervisor clustering. So you can do this safe in the knowledge that you're pleasing the SQL chap, or chapess, or lady, and you're pleasing the Hyper-V guy over here, because you've got that dual level of resiliency. However, some things to think about are, what happens in the event of a host failure? My SQL VMs are going to be sat on the same host. That's not particularly a good idea. From an affinity perspective, we need to ensure we can separate those workloads out. So how can we do that? And one point to note as well, if you are going to cluster SQL as a guest cluster, you're going to need iSCSI storage. You can't do it with fiber. Okay? So plan for separation. So if you want to keep those VMs apart, So imagine we've got a slightly bigger infrastructure than just 2 nodes. Imagine we've got 3 or 4 physical Hyper-V nodes, but we've just got 2 SQL VMs in a cluster or whatever. We can use a little hidden, but you'll find it online, again using your favorite search engine. You can find the anti-affinity class name, you can set that, and that will try its hardest to keep those VMs that are part of that group apart. We often use this with things like domain controllers as well. Okay? So in this example, for example, cluster group SQL1, SQL2, with the relevant properties in a group called SQL cluster, and it will try its hardest to keep those apart. If, however, you were on a 2-node cluster like I am, and you lost 1 node, it's not magic. You know, it's gonna, rather than not bring it up at all, it's gonna bring it up on that work. It's tried its best, it's tried its hardest to make you happy, but unfortunately it's gonna bring it up on that particular node in the cluster. Okay? But it will try, and there's a couple of links on the slide as well that will take you across to the relevant information where I got that from. However, there's another thing on there, heartbeat. What's heartbeat? Well, this is SQL's own heartbeat capability to say, oh, have I lost contact with the other node? Do I go into a failover situation at the SQL level? And on occasion, live migration could cause that if SQL feels like it's not been able to connect to the other node in time when the VM is flicked over to the other physical node. It shouldn't happen often. In fact, it shouldn't happen. But if it does, you may need to increase the heartbeat threshold for the SQL infrastructure just to account for that live migration. It shouldn't happen, but just something to be aware of. Okay? Because the last thing you want to do if you're nice and happily live migrating a virtual machine is SQL goes into HA and failover mode. That's not what you want. So I mentioned before overcommitting CPUs. Okay? And I said, you know, don't do it. Try to keep 1-to-1. Now the first 4 VMs on the left-hand side of that graph, we're introducing new VMs, up to 4. They have each got 4 virtual processors inside them. Okay, so by the 4th VM, we're utilizing 16 virtual procs. And the host they're running on has got 16 cores, 1-to-1. But look at the performance as we continue past, as we go to 5, 6, 7, and 8. It's still pretty linear, even though we're now overcommitting CPU. Now the SQL guys still recommend 1-to-1, and your workloads may not look like that in terms of as you go overcommitted. That's what you find, but certainly on SLAT-enabled, so new processor architectures within the last couple of years, you may be able to still increase that and go past that oversubscription metric. Okay, so something to be aware of. The relative throughput did drop slightly as it got past the 4 VMs, but it's still an acceptable performance hit, I think, in terms of what you're providing. Remember they were using, just to go back, fixed size VHDs and a decent amount of RAM for the virtual machine. But finally, the dynamic memory side. We touched on what dynamic memory was earlier on in the session. So this fluctuation of RAM based on changing conditions. And you're going to think, well, SQL's one of those workloads, it's just always going to want more and more and more and more. And that's not actually the case. SQL's actually a workload that can really integrate nicely with dynamic memory. And when it's not busy, it can give memory back to the system. And when it needs it again, it can take it on board. Because SQL Enterprise and SQL Data Center from 2005 to 2008 to 2008 R2, they've got hot add of memory as part of their capabilities. So when we hot add dynamic memory to the Windows OS, SQL can take advantage of that. Okay? And how we configure that in Hyper-V, we've gone through already. But in terms of considerations when you're utilizing dynamic memory in Hyper-V, you want to ensure that you're still right-sizing in terms of minimums and maximums. And I've got a better slide on this in a second. But you would also want to grant SQL Server the lock pages in memory service account capability, because that's going to let SQL manage its own memory usage more efficiently to give and to take back, rather than Windows and Hyper-V trying to do it. But providing you follow the guidelines that are laid out with the SQL team, what you'll find is that you can still utilize dynamic memory very efficiently, avoid performance drop-offs, and still utilize things like live migration and so on. Here's what I was talking about earlier. So 2005 Enterprise, 2008 Enterprise Data Center, and R2. When you're setting the startup RAM, make sure it's a minimum of a gig plus whatever SQL would normally need to start for your particular size workload. The reason that's important is the last thing you want is to start up a SQL VM and it start paging to try and get going. Help, I need more resource, and Hyper-V's going, there's more RAM, but the SQL's saying, I need more to start. You don't want to be in that situation. Give it a startup RAM of enough of what it needs, so right sizing. But the maximum of RAM that you would give it from a Hyper-V perspective would be that little bit bigger than what you'll specify in the SQL max parameter that you can specify for the database. I mentioned that buffer before. Reduce that buffer, that dynamic memory buffer, down to 5%. Because what we want to do is encourage SQL to manage its own buffering. Because then it can more accurately say back to Windows, the guest OS, don't need this memory anymore, you can have it back. Rather than Windows with its buffering saying, okay, well, you can have a bit more, now I need a bit, give me some back, and exerting unnecessary pressure on SQL. So yeah, utilize and reduce those figures down. And in terms of weighting, everybody's database is going to be pretty much important, mission critical, so you might want to slide that weighting slider right over to the right, because it's really important. You know, for your friend or your person you don't like, their virtual desktop, just reduce theirs down to counteract it. That's not best practice. I wouldn't condone that kind of behavior, obviously. So let's have a brief chat about elasticity and how we can scale very quickly. We've talked about scaling out on Hyper-V nodes into clusters, scaling up with SQL virtual machines, and how the performance is scaling pretty linearly across on Hyper-V. And the guest clustering can introduce better resiliency at multiple levels. So remember that best of both worlds. But how can I give you information that can enhance how quickly you can scale based on changing demands? Dynamic memory is only going to take us so far, but with Virtual Machine Manager, I can actually take us that bit further. And that's what I want to really showcase very, very quickly. Where's my mouse? Here we go. Resource pooling, elasticity. There we go. There we go. So let's have a look at this virtual machine here, this SQL VM. If we click on and we connect to it and we have a look, because what I want to talk to you about is how we can help you deploy SQL quicker to respond to changing conditions. So if anyone's used Virtual Machine Manager, you'll know that you can create templates of operating systems. So a Windows Server 2008 R2 template. And whenever I deploy that template, it's sys-prepped, so it's generalized. I deploy it across the network onto a host and spin it up. And within 10 minutes, I've got a new virtual machine up and ready to go. But it's just an empty Windows VM. I need a data tier provisioning quickly. So you think, well, I'll have to get the SQL binaries, I'll have to install it, I'll have to do the next, and that's going to take a lot of time. How can we automate that process more? And that's what I want to show you here. Because what you may not be aware of is within the installation and the advanced tools that exist within SQL, and if you're like me, you'll normally just click on installation and then plow straight ahead and install SQL. But if you go down to advanced, you can actually prepare an image of a standalone instance of SQL Server ready to be sys-prepped. So a sysprep aware instance. And that's beneficial because if I look in my C drive of this virtual machine, and the thing to remember about this VM is it's going to be our gold build. It's going to form our template very shortly. If I go into the C drive and I go into here, you can see there's lots of files. There's a BAT file or a CMD file that's going to be used as almost like a run once command, and that's going to pass in stuff from this configuration file, like the instance name and what it needs to perform, so complete the image. Do it silently, don't display it to the user, and so on. And you can populate all of those fields. And what that's enabling me to do, if I close this out, come out of this virtual machine view, and close that, and go to the library, which is where we store these templates in VMM, Virtual Machine Manager. I click on a template, indicated by the little square, and I click on Properties, and I go to OS. Now, normally when you're deploying a template using VMM, you input the name, or the little star means randomly generate one, but on deployment time you can choose an admin password that makes sure all the admin passwords on all your servers are the same. That's a good thing. Product key, time zone, guest OS, doesn't make a difference which one you're installing. Domain join, so as part of the deployment process from this template, it's joining it to the domain, which saves us effort and a reboot. But this here, attaching an answer file, an unattend.xml file to automate the installation of Windows a little bit further. But this is the key one. Commands to be run at first logon, C drive /lucerne install SQL.cmd. That's that little bat file that's going to run. It's going to pass in all those different configuration items, and when you know it, when you get to the stage when you've deployed this VM, within a fair few minutes, you've got a data tier that you've expanded elastically, okay, responding to changing conditions. Okay, so that's how we can use Virtual Machine Manager to very quickly scale up. Now, if I go back to my virtual machines, in fact, I'll leave that for now because we've looked at dynamic memory already, so it was just a bit extra on DM, but we've seen that already. So final bits to wrap up. I talked right at the start about how System Center provides that extra value. We've just seen how VMM can, with its templating and its integration with the way we can sysprep and deploy SQL very quickly. DPM can be used to back up SQL up to every 15 minutes, just the delta changes, so just the change blocks, and we can restore up to the last committed transaction. So even if you've gone beyond the last 15 minutes, if we can get that last transaction, we can restore that back. And one of the nice things about DPM that not a lot of people know is that we actually provide a capability within DPM called DPM to DPM for DR. So if I've got a DPM server, a data protection manager server protecting my core infrastructure on site A, and that's my main production site, and I've got another DPM server over here on site B, I can point this DPM server at that DPM server and back it up across the WAN, okay, securely across the network. And what that means is, should site A go bang, I can restore onto site B. So I can restore the VMs, and I could restore the workloads, and so on. Okay, so it gives us a granular level of protection for those key workloads, Exchange, SQL, SharePoint, and so on. And it's one agent to protect all of those workloads. It's not a DPM for SQL or a DPM for SharePoint. It's one agent. But very quickly, if we have a quick scoot at Ops Manager, and some of the stuff I can show around SQL. So Ops Manager is monitoring our infrastructure. And if I look at our SQL, you'll see the management pack that I've imported gives us a lot of different choices here, and we can look at things like the free space of our database. So have a look at in graphical format. Let's have a look at, let's filter by SQL 2008 SP1, so I can build up some quite rich views. There's the AdventureWorks database, the Service Manager database, and we can see that gradually over time they're going to run out of space, and we can start to use that to start to do some of the what-if analysis. But look at the side as well, SQL database tasks. So I'm getting common tasks that are applicable to SQL Server right within Ops Manager, and that applies throughout Ops Manager. If I click on a Windows server, I'll get ipconfig and ping and other useful tools. If we look at the health of our databases, I think, in fact, if I look at the alerts, because some stuff is not incorrectly configured, but we've got a few issues, but then it wouldn't be a demo and a monitoring demo if I couldn't prove things were going wrong to you. But you can see here, primary database, file group is running out of space. Now, there'll be SQL people in the audience thinking, that's a big problem. Now, in our lab environment, it's still probably a big problem because it's powering pretty much everything in there, and there's no mirror or cluster. But still, I know about it now. It happened 5 days ago in 15 hours, so a more proactive user of Ops Manager might have dealt with that by now, or fed it off to the SQL, you would hope, or fed it off to the SQL team, because that's the nice thing. If I'm a SQL guy and all I'm interested in is SQL monitoring, then I can create my own workspaces that just have the views that are important to me, like the SQL stuff, and the notifications come as part of that. Now, I might have to assign that to one of my colleagues to have a look into to help me fix that. But if I look in here, Open, Health Explorer, like the whole delegation side, this knowledge that's going to come back as part of Health Explorer, in fact, it's loaded on this one. Let me just drag it across. Oh, very quickly. There we go. We can see the database is running out of space. There's knowledge. What causes this? Well, inadequate file configuration settings or inadequate space. It's pretty self-explanatory. But what can I do to fix that? Enable auto-grow and other different resolutions as well. So it's arming you with that knowledge about the workload. And it's the same kind of thing for Exchange, the same kind of thing for SharePoint. It's arming you and helping you do more with less. So everything's working in my environment. So I don't know there's a problem with that file space, but there obviously is. We're publishing some guidance. Everything I've talked about today is going to be available from those links. If you want to build it on your own sites, we're providing reference architectures. But if you want to buy it in as an appliance to run SQL, virtualized, and other workloads that lend themselves pretty nicely to OLTP performance and that kind of characteristic, then the appliances may be something that's up your street. But again, the slides will link off to that. No more breakout sessions this week, but if you do want to check any out online, there's some good ones. And you won't find me later at the Server and Cloud TLC. But I hope you've had a useful week. And yeah, have a safe journey home. Thanks for your time. And if there are any questions, please come up while I'm packing up. And thank you very much.